Um, Hello, everyone. I am Ali Hamidoglu. I will moderate this beautiful webinar. Um, Shortly, let me introduce myself. I serve as the representative of IEEE Turkey YP Blockchain and Control System Society, and currently working as assistant professor at the math department of Bahçeşehir University. Today, we open a first webinar related to blockchain in the webinar series of IEEE Turkey YP. And in this field, I would like to introduce my very important guest and my friend, Dr. Mubashir Rehmani, who will deliver us a talk entitled The Metaverse, Cryptocurrency, NFTs, and Blockchain. So before providing you a short abstract of this exciting presentation, let me first introduce Dr. Mubashir kindly. He received his baccalaureate degree in computer systems engineering from Mehran University of Engineering and Technology in 2004 in Pakistan, and his master degree from the Paris Sud University in 2008 in France. And finally, he obtained his PhD degree from the University of Pierre and Marie Curie in 2011 in France. So he's currently working as lecturer at the Department of Computer Science in Munster Technological University in Ireland. He's serving in the editorial board of several top-ranked journals such as Nature, Scientific Reports, IEEE Communication Surveys, and tutorials, and IEEE transactions on green communication and networking, and many others. And in this talk, let me shortly say in this talk, Dr. Mubashir introduced Metaverse, cryptocurrency, and NFTs, where one can design or implement his own cryptocurrency and NFTs in the field of blockchain. So some operational aspects of famous cryptocurrencies such as Bitcoin, for example, Ether, Luna, and so on, together with their implementations, will be provided afterwards. So then all concepts will be connected to blockchain, and after that, some technical details such as consensus algorithms and hashing, digital signatures, and encryptions will be discussed at the end of this presentation. And after the presentation ends, we take several questions related to the topic. So from, of course, from the audience and during the talk, and you can, during the talk, you can use the comment session, please, for questions and comments, which is, you can see right side of your right side of the video. You can see the column session, right? You can use your questions and comments there. And of course, I will ask first questions. So and then take your question at the end. And I strongly believe that you will enjoy this talk. And most important part, you will gain some crucial knowledge related to blockchain technology, thanks to Dr. Mubashir. And in advance, I would like to thank you, Doctor, for your precious time and support. And I kindly leave this platform to you now, sir. So please proceed now. Thank you. Thank you very much.
Thank you very much, Dr. Ali, for inviting me for this talk from IEEE Young Professional Turkey. So today I'm going to talk about Metaverse, cryptocurrency, NFTs, and blockchain. So can you just confirm me if you can see my slides?
Yes, Doctor. Yes.
Okay, perfect. So basically, as you can see over here, we have different terms. For example, cryptocurrency, Web3, Metaverse, non-fungible tokens, and smart contracts. So let me talk about first cryptocurrency very quickly. Cryptocurrency is basically a digital currency, and there are numerous digital currencies available right now, ranging from Bitcoin, Ethereum, and there are more than thousands of more than 1,000 cryptocurrencies available right now in the market. And we have decentralized finance, DEFI, which you can see over here. Decentralized finance basically is a peer-to-peer financial service. So it offers financial instruments without relying on the brokerages or exchanges or banks by using smart contracts on a blockchain. Similarly, we have DApps. So DApps is a decentralized application, which is an application that can operate autonomously, typically through the use of smart contracts that runs on a decentralized computing blockchain or any other distributed ledger system. You may have heard about Web3. So Web3 is the new internet architecture with the concept of decentralization using blockchain and cryptocurrencies. And finally, we have DAOs, which is basically a decentralized autonomous organization. So as you can see, all these key terms, including non-fungible tokens or metaverse or Web3 or cryptocurrency, all of these are relying on blockchain. So blockchain is the core. Blockchain is the core or behind the main technology that runs all these cryptocurrencies or Web3 or metaverse or DApp or non-fungible tokens or even decentralized finance. So that is the important thing that we need to consider throughout the duration of this talk. Now, I want to give a practical example of buying and selling a virtual land on internet, and then I will relate it to metaverse and cryptocurrencies and blockchain. So this is basically a website which you can go and browse. It's nextearth.io. It's a website, so you can go and visit this website, and this website provides you land ownership for metaverse. So here what I did is that I go to this website and I search for France, and then in France I selected Paris, and then I selected Eiffel Tower. So as you can see over here, I selected the area of Eiffel Tower, and when I selected the area of Eiffel Tower, it shows me who is the current owner of this digital land, and it also shows me the land price, which is 311,000 USDT, which is a currency. And if I'm interested to buy this land, virtual land, I can buy this land by paying it in the form of USDT. So how I will pay this? So first I will go to any cryptocurrency exchange. There I will buy this USDT cryptocurrency by exchanging US dollar or any euro or any other currency. And then with the USDT amount that I have, I can then buy this particular land. Similarly, I go and see some other land places. For example, this is a university in Pakistan, which is National University of Science and Technology, just to give you an example. And here you can see the price is 1,200 USDT. The price is very low. The reason is that in the Eiffel Tower, the digital land of Eiffel Tower is very much famous among the people, while this particular land of university in Pakistan is not that much in competition. But if someone, if the people are interested in this land, they can buy it, and then the price can go on. So you can see we can buy these digital lands from this website to use in metaverse. Now, what technologies we used? So first we use cryptocurrency to buy this land. Then we use NFTs to make this virtual land record unique. You know, when you buy this virtual land of Eiffel Tower, you will get an NFT for that. It means you are the unique buyer. You are the unique person who bought this land, and through these NFTs, you can easily track down who is the previous owner of this land and who is the current owner of this land. And behind this, a blockchain is used behind both cryptocurrencies and NFT. And we will be using this digital land in metaverse, where this land can be used. So you can see we are combining all these concepts in metaverse and using blockchain, NFTs, and cryptocurrency. Now, this is another website which is Earth 2. This is a similar website, and it also provides you to buy digital land. Uh, and here you can see I select the same location, same Eiffel Tower location, but here the price is different, the market value is different, and it is different from the previous one. It can be seen in the form of bonds, and then we can also see it in the form of cryptocurrency. So you can see these are two websites where we can bound the same land of Eiffel Tower. Now, this is another website which is known as Decentraland, and this is basically a first ever virtual world owned by the users, and you can go and explore this metaverse, and you can develop your virtual assets in this platform. Now, the question is that uh, when you buy a virtual land out of this out of any of these websites, uh, uh, will it be legally accepted in the country in which you are buying? For example, when you buy the digital land, and if in a particular country they do not accept cryptocurrencies, then definitely there will be some implication for that. Similarly, when you uh, buy the digital land from any of these websites, so will there be any issue in terms of ownership of this virtual land? Because uh, there are two different websites who are selling the same digital land, and I'm buying it from one website with cryptocurrency, and I'm the unique owner according to that website. But another person who is buying the same digital land from another website, so what will be the legal implication? Because the land is single, okay, but different websites are owning that land and selling it. So if we think about a physical land can be bought and sold on the website, but that physical land will be a unique land. However, here in this case, when we are talking about virtual land, we can have multiple entities owning and claiming the ownership of the land. So this may cause some issues. Similarly, when you have multiple NFTs for the same virtual land, then this is not really depicting the real environment, because in real environment, in real situation, we have a single physical entity and we have a single owner at a particular instance. But here we have, although same digital land, but there are multiple parallel instances or uh, records of the same land, and people are buying and selling it. So there is a serious issue in terms of trading and buying of this land. Similarly, when these lands are very costly, virtual land, and when you use cryptocurrencies and buy and sell it and get some profit, how will it come under the tax regime? Because you have to declare your assets to the revenue department, and when you will buy and sell and make some profit out of these land, so there may be some issues in terms of income tax law of the country in which you are residing. uh, Moreover, when you submit your annual income tax, you have to mention all your assets. So here, when you buy any digital land, what will be the implication? Will you consider this as a land asset, or how it will be considered in terms of legal implication? So the summary is that we can understand that how the trading of this virtual land digital assets are done over the internet, and uh, these virtual lands are basically not coupled with the actual land or real owners of the Eiffel Tower, and this will be a serious implication for the future of future trading of the over the metaverse. Because if there is an NFT that is directly coupled with the digital with the physical asset, then we can say that it's a unique thing. But here you can see through this example, there are multiple NFTs of the same digital asset, so it may have some implications. So now I move towards cryptocurrency. So as you can see, there are more than 17,000 cryptocurrencies exist today. You can go to any marketplace and see there are numerous. I am just mentioning few of them. So the famous one are Bitcoin, Ethereum, XRP, Litecoin, and you can see the market capital is huge. Yeah, if you combine just two cryptocurrencies, Bitcoin and Ethereum, they are more than 50% of all the market capital of all the cryptocurrencies. And the price is also very much huge of these cryptocurrencies. So here I'm showing you the Bitcoin price in US dollar. So for the last 1 year, so you can see the price varies very significantly and goes ups and down. So if someone buy, let's say, one Bitcoin, let's say in November or in July, it was about 30,000 US dollar, and after few months the price goes to double and it becomes 60,000 US dollar. So in few months uh, they make their profit double, and it's a huge amount. It's a huge amount for a single Bitcoin. But there is another side of the coin. If someone buys it in, let's say, in October 2021, and now it is selling right now, the price is less than 20,000 US dollar. So the price went very exponentially low. So the person who invested at that time, they may lose their whole investment. So this is because of the very volatility in the cryptocurrency market, and due to this volatile feature, uh, it is not considered as a currency by the researchers who are in finance or who are in economics, because of this huge variation. So when we look at the this last 7 day price fluctuation of Bitcoin in USDT, so you can see even the price is fluctuating from 19,000 US dollar to 22,000 US dollar. Just you know, 4,000 US dollar variation in a in few days. That's a huge variation, and that variation will make this cryptocurrency infeasible to be considered internationally, to be recognized internationally as a currency. People can invest and make some money and may lose some money, but uh, uh, but in front of the financial institutes and finance researchers, this is one of the issue with the Bitcoin cryptocurrency. So now I move towards cryptocurrency marketplaces and exchanges. So you can see over here we have this is the Coinbase website, where you can have different cryptocurrencies where you can buy and sell. This is a marketplace. Then you have this is Binance, which is one of the famous uh, uh, marketplace which has a lot of cryptocurrencies over there. Similarly, Bitfinex is another marketplace where one can buy and sell the cryptocurrencies. And now here there are some examples of wallets. These are the wallets which one can install in their computer or mobile, and through which through these wallets they can access and make transaction for the cryptocurrency. So these are few of the famous cryptocurrency wallets. Now, there are some features of cryptocurrency. First, we call cryptocurrency because it uses strong cryptographic algorithms. So when we say that strong cryptographic algorithm, it means that we perform secure communication in the presence of adversaries, and it used some famous cryptographic algorithms like encryption, digital signature, hashing. And these cryptocurrencies are generally computer-based currencies. They are known as digital currencies. They are managed through a computer network which is known as blockchain. And another unique feature is that they are not controlled by the central authority like banks or governments, and we can purchase these cryptocurrencies from the cryptocurrency exchanges or marketplaces. And if that is one way. Another way is to earn these cryptocurrencies through mining. So when a miner wins in the mining process, they get the mining reward as well as the transaction fees. So all the transactions that they gathered in a block, they will get the reward as well. Now, in terms of other features, there are some other distinguished features. First, uh, Bitcoin cryptocurrency is basically a transaction ledger. Transactions are recorded in the ledger, and Bitcoin does not have any intrinsic value. Means like gold has some intrinsic value, but Bitcoin cryptocurrency does not have any intrinsic value. Similarly, Bitcoin in itself does not have any benefit. For example, when you use any software like Microsoft Word or any graphic software, that is digitally exist, and you can use it, and it has some worth. You can buy the software from any website or from any shop. But Bitcoin, if you take it digitally, it does not digitally exist. It's just the entry in the distributed ledger in a blockchain. So it cannot be in itself used, and it does not have any worth in itself. So Bitcoin does not physically exist like the euro coin or any other currency. It does not physically exist. Even it does not digitally exist. Digitally exist means that, like, if I take a picture, I can send and attach that picture through my email, but Bitcoin cannot be attached to any email. uh, or when we say that we transfer Bitcoin from one person to another person, it means we update the state of the ledger. The state of the ledger is updated. There's a whole process, and then we say that okay, the Bitcoins are transferred from one person to another. Similarly, when you install a wallet on your system or mobile phone, then you access your wallet with a public private key. Public private key is similar to your username and password, or in banking term, it's your bank account and your bank account number and your password. So in the context of cryptocurrencies, in the context of Bitcoin, you have wallet. Each wallet has a public key, which is similar to your account number, which can be visible to anyone, and your private key, which is similar to your password. So when you access your wallet, it basically attach to the ledger, and it shows you your balance in Bitcoins or Ethereum or whatever. And these coins as such do not exist. And when you transfer Bitcoin, basically you are updating the state of the ledger. And finally, Bitcoin is not even a software, it's a protocol, and the code is available online on GitHub or on Bitcoin website. You can yourself download the code, and you can change it, and you can create your own cryptocurrency. And even lot of cryptocurrencies were based on Bitcoin cryptocurrency because of this open access feature. So here I'm mentioning you, uh, I visited blockchain.com. It's a screenshot of that website. So this is the block zero. This is the first block of Bitcoin blockchain when the Bitcoin blockchain was created. So you can see the difficulty at that time was one, means anyone uh, can easily mine the block, and the price was 50 Bitcoin, and this is the hash value, and there was only one transaction in that box in that block. So this block is known as Genesis block. It was mined on January 3rd, 2009, and the total reward was 50 BTC, 50 Bitcoin at that time. So this was the first block that is added. This was the first time when Bitcoin cryptocurrency was created, and it never existed before. Now, when this mining occurred, and the miner got this 50 BTC as a coin-based transaction. Then that newly generated coins were transferred to another person, and this is how they just change the the address corresponding to those 50 BTCs, and they are known as UTXOs, unspent transaction output, UTXOs. So if you have 50 UTXOs, it means you have 50 BTC in your balance. And when you spend it, when you transfer it, it becomes STXO. STXO means spent transaction output. So this is how the whole ledger of the Bitcoin blockchain get maintained. So this is the address, and as you can see, this address will further transfer those bitcoins to other addresses, and you can keep track from where those 50 bitcoins were generated, who own, and then those BTCs were transferred to these addresses. And you can see the green icon. Green icon shows UTXOs, means these addresses didn't spend their Bitcoin, and the red icon shows that these are the spent BTCs. STXOs means they cannot be further utilized. So this is how one can track all the BTCs generated and transferred, and the whole chain publicly online. Now I just want to discuss about energy consumption of Bitcoin, which is due to the mining process, which is an important factor. So basically, miners are nodes which solve the cryptographic puzzle. So there is a cryptographic puzzle, and that cryptographic puzzle need to be solved by the miners. And if a miner is successful in the mining process, the miner will get rewarded by the mining reward as well as the transaction fees. So there are four main factors that contribute to the energy consumption of cryptocurrency mining. First, the hardware computing power, the network hash rate, the difficulty, and the thermal regulation of the hardware. So when you combine all these things, it becomes a major factor for the energy consumption of the miner. So this is one of the device that one can buy. It is known as Ant Miner Bitcoin Miner S19 Pro, and you can see it is more than 5,000 US dollar. And this is a dedicated CPU-like hardware device, which may contain GPUs or other high speed microprocessors. And you can use these microprocessors or uh, you know SMTs for in the mining process. And this alone may not consume that much energy, but when you combine it and you let's say you buy such a container which contains, let's say, 210 Antminer, it is capable of over 1 megawatt operating capacity, and the price is 1,000, you know, 111,000 US dollar. That's a huge price. And when you combine these entities, Antminer devices together, it consumes a lot of energy. And although you can successfully mine some bitcoins as well, but the energy consumption is a major factor. Now you can see over here, this is basically the Cambridge Bitcoin electricity consumption index, and it is being measured by uh, uh, the Cambridge University, and they have the online website which can be used to monitor the energy consumption of uh, of the of the Bitcoin mining process. So you can see in Pakistan, 103 terawatt hour per year is the energy consumption. Netherlands has the same. Then we have Argentina and we have United Arab Emirates, and Bitcoin is lying in between. It is consuming more or less the same amount of energy. So if you combine the whole energy consumption of Bitcoin around the globe, it is consuming the same amount of energy like a country annually. So it's a huge amount of energy, and that is the reason why the European Union is basically making laws to not allow mining within the European region because of this energy consumption. And that is the reason why Ethereum is now moving from proof of work consensus to proof of stake consensus algorithm, because proof of stake doesn't consume that much energy as proof of work consensus algorithm. So now we talk about another aspect: who held most of the wealth and power in Bitcoin. or is Bitcoin is a decentralized currency, or can any government institution or any person manipulate the price of cryptocurrency or have control over it? So here you can see these are the data that I collected from this blockchain.com website, and I collected this on 5th of June 2022. And as you can see, more than 50% of the mining has been successfully carried out by 4 or 5 or 6 mining pools. So these mining pools have the whole dominancy in the cryptocurrency, Bitcoin cryptocurrency, and they have the whole power. 47% power they have. If some of them combine or make a collision, they can control the whole Bitcoin cryptocurrency. So it is well established in the scientific literature, in the scientific community, that these mining pools are the actual uh, uh, entities that controls somehow the mining process of the Bitcoin blockchain. And this is against the basic principle of blockchain and Bitcoin, because when the blockchain was introduced, Bitcoin was introduced, it was said, it was mentioned, it was claimed that the Bitcoin cryptocurrency will be working on the blockchain principles, and it will completely be a decentralized currency. But with the passage of time, with the evolution of mining pools, these mining pools took over the mining process, and now they have a lot of say and lot of influence in the mining process and in the price fluctuation of cryptocurrency. Now, this is a recent study conducted by a few researchers, and I have mentioned the link of the paper over here, and uh, uh, the news of this paper also published in New York Times, but the scientific paper is available over here. The link I mentioned over here. So this paper studies that how Bitcoin cryptocurrency came into existence. So here you can see this one small square represents 1,000 Bitcoins, and this pie basically shows you who owns how much cryptocurrency. So you can see this agent number one, Satoshi Nakamoto, who was the creator of Bitcoin cryptocurrency. He owns the highest amount of Bitcoin cryptocurrency. Then you have agent three, agent five. So you can see these are the actual owner of the Bitcoin, and this information is already available on the Bitcoin ledger. So basically, in the first 2 years, when the Bitcoin was created, January 3rd, 2009, and when you look at the complete 2 year cycle, you can see that 64 key players mined most of the Bitcoin. It means that it is against the Bitcoin's egalitarian promise, which says that there is not no classical distribution of income inequality emerge. So basically, we have the Pareto distribution in the normal economies, where 20% of the population controls 80% of the wealth of a particular country. And Bitcoin came up with this idea that uh, it will not repeat the same thing, and the currency will be decentralized, and everyone have access, and everyone own this cryptocurrency. But as you can see, a small fraction of miners held most of the wealth and power, and it is against the Bitcoin's egalitarian promise and the promise made by the Bitcoin cryptocurrency. Now there is another issue. Uh, it has been claimed that nobody can control cryptocurrency Bitcoin, but it is not a fact. So here you can see this is the Celsius network website, which has 1.7 million people who had their accounts, and they froze their website, and all the people who were having their account in their website, they lost their uh, uh, cryptocurrency, and now they are in the court in US. And with this frozen factor by the Celsius network, the Bitcoin price and Ethereum price, they both dropped significantly, and they dropped around 40 to 50% in that time. So you can see this Celsius network they have the control of this 1.7 million customers account, and they froze their cryptocurrency accounts, and all of those people cannot buy and sell and use that cryptocurrency, and this has a direct impact on the price of Bitcoin and Ethereum. So when we claim that nobody controls, that is not scientifically correct, because as you can see, miners have their own influence. These network operators, currency operators, they have their own influence. Similarly, marketplace owners, they have their own influence on the on the cryptocurrency. So uh, Bitcoin is not a decentralized currency, although at the starting it is based on blockchain, and blockchain is completely decentralized. But with the passage of time, Bitcoin uh, did not follow the principles of the blockchain, and then you have these mining pools, or Bitcoin web wallet operators, or Bitcoin software protocol maintainers, or developers, uh, or exchanges. They have a lot of influence and a lot of power on this whole Bitcoin cryptocurrency. And I just mentioned a paper over here, scientific paper, who have conducted a detailed study about whether Bitcoin is considered as a decentralized currency or not. And there are some other papers as well, which claims that Bitcoin cannot be considered as a decentralized currency. Now there is another case study which one may see. Recently, we had Terra USD Luna collapsed, and again, you can see this is the Terra Classic to USD chart. And this cryptocurrency just collapsed, and a lot of people lost a lot of their money because of this collapse. So we cannot say that nobody controls these cryptocurrencies. There are people behind these cryptocurrencies who make changes in the code of the cryptocurrencies, who own mining pools, make influence on these cryptocurrencies. Now, if you are interested in further exploring and visualizing Bitcoin and Ethereum, so this is one of the best website. It provides you real-time information about the mining activity, and it is being developed by researchers from France. And here you can see which mining pool is dominating, what uh, uh, what uh, uh, what blocks are being mined, which mining pool plays a crucial role in the mining process, and so on and so forth. Similarly, this is another website, ethstats.net. It shows you statistics about the Ethereum cryptocurrency. Now, the question is why Bitcoin was famous. Where was Bitcoin spent, and can Bitcoin be considered as gambling? So basically, when first Bitcoin was announced, no, as you can see over here, there were very few transactions in the start in 2010, 2011. But then they use this Satoshi Dice D app. So this D app says that it has different multiplier, and they have also mentioned few addresses. So you buy a few cryptocurrency, and you send it to any of these addresses, and then they will make a gambling, and if you win, you will get in return the multiplier of that amount. So people in the start, when the Bitcoin cryptocurrency was not that much famous, they launched this Satoshi Dice D app, and people when say that, okay, if one has bought, let's say, 5 Bitcoin, then they send it to the address of this 10x multiplier, and they get 50 Bitcoin in return if they win in the gambling. And if they didn't win, they may lose 5 Bitcoin. Similarly, you can see there is 50x multiplier, 100x multiplier, and 1000x. And when you look at the transactions on one day, the transactions are huge. 54,000 transactions per day were happening over this website. So that was the point where Bitcoin get introduced to the public, and people took interest because they are getting a huge amount of return as a gambling. And now this website is using another cryptocurrency, which is the hard fork of Bitcoin. It is now BCH. So hard fork is that when you have two chains and the currency get divided. So they are right now they are using BCH, which is another variant of the initial Bitcoin blockchain. But previously, this website were using the Bitcoin cryptocurrency BTC. Now, the question is there any alternative to cryptocurrency? Yes, there is an alternative. There are countries which are working on, for example, central bank digital currencies. For example, we have UK central bank digital currency CBDC. The Bank of England can produce it, and it will basically work like a digital currency, and these digital currencies will be regulated and monitored and controlled by the central bank. So if any customer loses or have a risk, they can go back to the central bank or the bank for getting some assurity. It is not similar to cryptocurrencies, where if you lose, you may not go and claim to anywhere. Then you have the digital euro. Digital euro is an initiative by European Union, and they are uh, trying to make legislation so that we can have a digital form of euro. And this digital euro would not replace cash, but it will rather complement it. And the euro system will continue to ensure that all citizens across the euro have access to this cash. So as you can see, these were few alternatives that are being adopted around the globe, and there are some other initiatives as well in Canada, in other countries, in terms of as an alternative to cryptocurrency. Now I move back to blockchain. So as you can see, blockchain has a lot of applications. It is the core technology behind Metaverse, Web3, cryptocurrencies, NFTs. So basically, a blockchain is like a database, okay, but it does not have a central server, and you create data structure based on linked list, the data structure, linked list data structure, and you combine all those records blocks all together, and the record will exist around multiple machines. So before the arrival of computers, we have assets. Everyone has assets. For example, land, car, or any other thing, important thing. So these ledgers were maintained with the help of manual registers or manual copies before the arrival of computer. But then when the computer arrived, people start saving these records on computers using spreadsheet or Microsoft Word or other softwares. And then with the evolution of with the passage of time, these records were maintained using dedicated softwares. These softwares are known as database management system, and we have huge amount of information that is being managed and controlled by these database systems. uh, so if the central server of the database goes down, uh, all the record will not be available. For example, when you have your account and you have your ATM card or debit card, you try to access to the central server, database server, and you access the record with your username and password, and then you can see the details. And if you want to modify, the server has to validate that information. And if the server goes down, the whole network goes down. But in blockchain, you are just removing this central server that I just mentioned over here, this central server, and instead of that, the copy of the whole record will be shared among all the computers, and all the computers will be responsible for making a collective decision about the status of the record. Now, how transactions in traditional banks and blockchain happen? So basically, in a banking model, you have a central bank which regulates or oversight all the process. But in Bitcoin or in cryptocurrency, you don't have any central entity, and it's the consensus algorithm that looks after or that controls each and everything. Similarly, in typical banking model, money is created through loans, and the government issues and publishes new notes or new money. But in Bitcoin, the mining is the process through which new cryptocurrency is being generated. In the context of Bitcoin, we have a finite supply, but in the context of money in the banking system, we have virtually unlimited supply. So there are some details of the differences between the banking model and the Bitcoin. Now, when we look at how traditional banks transfer. So let's say Alice is the sender of the money, and she wants to send 1,000 US dollar to Bob. So what Alice will do? Alice will access their bank's website or application with the username and password. And if Alice has sufficient balance, she can then mention, the address of Bob address, and then she can send that amount. So here you can see Alice basically first access to her bank and get access to the bank's ledger, and then she transfer to Bob, and Bob's bank will receive the request, that transaction, and once Bob's bank received that transaction, Bob's bank updated the ledger state of the ledger of Bob's, and if in between there is any issue occurs, then the central bank will settle down all the issues. The central bank will look after all the overall operations of all these banking systems. So this is the traditional model of transaction being happened in a banking system. Now, when we move towards a blockchain system, in a blockchain system, since there is no central entity, so a complete copy of the ledger will be residing on each and every computer. Now, if Alice make a transaction, then this transaction can be received by Bob, but all the other nodes in the system will update the state of the ledger on their own computers, and this will be carried out with the help of consensus mechanism. And consensus mechanism is basically in Bitcoin, it's a proof of work, a cryptographic puzzle that the miner need to solve. So any node in this network can become the miner, and if that node has sufficient computational power, they will be able to successfully mine the block, and that information will then broadcast to the whole network, and all the other nodes will update their state of the ledger. So this is one of the detailed description how how basically a block creation process is being carried out. So first, any transaction occur, then this transaction is validated initially. If the transaction is valid, then the transaction gets stored in the mempool. Mempool is a local memory in each of the computers, and then any miner node can access to the mempool, and then assemble multiple transactions and create a block, and then try to solve the cryptographic puzzle. If the mining node is able to successfully solve the cryptographic puzzle, that node will be declared as the winner, and that node will get the coin-based transaction, the reward of the mining process, and then that miner node will communicate that information, the block, to the whole blockchain network, and then other nodes will verify, and then that block will become the part of the ledger. So I already explained you the concept of UTXO. So here you can also see that there are input UTXOs and there are output UTXOs. So all the ledger in the Bitcoin blockchain is managed in the form of UTXOs. So the output UTXOs can never be greater than the input UTXOs. So now, just to give you a quick example how physical assets are transferred. So here you can see, let's say this is a world map, and someone is there, Alice is there in New York, and she wants to transfer this car physically from New York to Sydney, Australia, to Bob. Now there are two options. She can send this car with the help of cargo aeroplane or cargo ship. So this is how a physical car can be transferred from one part of the world to another part. Similarly, when we talk about money, if money in the physical form, if Alice wants to transfer it to Bob, there are multiple ways. First, Alice asks someone to travel to New York to Sydney and physically transfer this money, hand over this money to Bob. This is one option. The second option is that Alice transfers this money to someone in New York, and that person asks someone in Sydney to deliver the same amount of money on behalf of Alice to Bob, and this is known as bill of exchange. Another possibility is that Alice transferred this money through money exchange services such as Wise or Western Union, or through the banking system. So these are the ways through which Alice can transfer physical money from New York to Sydney. Now, when we look at let's say a digital picture. So Alice has a digital picture, let's say a picture of apples. Now, if she wants to send this picture, digital asset to Bob in Sydney, there are these are the ways. For example, Alice send this digital picture to of apples to Bob through an email attachment, or save it in a USB or hard disk drive, and then send this USB drive to Bob in Australia. Or Alice can use file transfer service or cloud service to send this digital picture. So this is how Alice can send a digital asset, a digital picture from one physical location to another. Now, if Alice wants to transfer digital money, what is the possibility? The possibility is that Alice transfers this digital money through USB or hard disk drive, or as an email attachment, or transfer this money and ask someone to deliver it to Bob, or use central bank digital currency, or use any banking or banking system, or Alice can transfer this digital money through blockchain without any intermediary, third party or bank, and that's how we have this concept of cryptocurrency, Bitcoin or Ethereum. But remember that these digital currencies, they are not unique. They don't have the identifier or serial number like the physical money. So that is an issue that is being investigated in the scientific literature. Now, this was a few of the examples how we can transfer physical assets or digital assets from one place to another. Now, how actually Bitcoin transfers? So basically, here is an example. Here you can see on the top left hand side, you have one computer. This computer is owned by Alice, and she has a complete copy of the ledger. So there are 4 nodes. There are 4 computers around the globe, and each computer has the complete copy of the ledger. And in this copy of the ledger, there are 2 parts. One part is pending transaction, and another part is ledger, which is the actual working copy of the ledger. In this ledger, we have transaction 1, transaction 2, and transaction 3. So at this particular instant of time, as you can see, on all the computers, they have the same complete copy of the ledger. All these transactions are there. Now, Alice wants to send Bitcoin. Okay, so what she will do, she will include a transaction, and then she will that transaction become part of the pending transaction. And then once it become the part of the transaction, it will not be written in the actual ledger, and first this transaction will be communicated to all the neighboring nodes. So as you can see, this transaction 4 will be communicated to all the neighboring nodes, and then they disseminate to all the other nodes. So all the computers will have this transaction number 4 in their pending transaction list. They have the verified ledger copy of the ledger, and then they have the pending transaction list. Now, uh, uh, once this information is there, then there's a minor node, which can be any node, which will win the mining process. And once that mining process wins, they will then let's say communicate this new block to uh, all the participating nodes. And once this new block is broadcasted, then this transaction number 4 will be included in the actual copy of the ledger. And this is how all the state of the ledger is being updated. So as you can see, this ledger will say who owns this Bitcoin, and then you can see once the state of the ledger is updated, in this transaction it is written that Alice sent this much amount to Bob. So this is how transaction in Bitcoin occurs. And when we talk about blocks forming in blockchain. So it occurs, it has a structure like this. So each of the blocks, they are linked together with the help of previous hash of the block. So hash is basically a cryptographic algorithm. They use different types of hashing algorithm. So I think we have passed a sufficient amount of time. So I just want to stop my presentation, and I just want to cover the last topic, which is non-fungible tokens. So basically, non-fungible tokens, they are very famous. We have NFT marketplaces. So these marketplaces, they offer different types of NFTs in the market. For example, we have OpenSea, we have Nifty Gateway, and as you can see, they have a lot of collection of NFTs. We have NBA Top Shot. These are also NFTs. We have CryptoPunks, and there's a huge collection of these NFTs. And Rarible is also another marketplace where you can buy. So these NFTs are basically non-fungible tokens. So when we talk about assets, there are two types of assets: tangible assets that are physically present, and intangible assets that are not physically present. And we can also say that we can have a digital asset as well. These digital assets can be video, audio, JPEG images, documentation, or cryptocurrencies. So these digital assets will be non-tangible. That is, they are not physically present. So we can classify these assets into fungible assets and non-fungible assets. So fungible assets are identical and mutually interchangeable. They can be exchanged for others for the same value and type. For example, when you have a piece of gold, it can be exchanged with anyone around the globe with the same amount. And the currencies, for example, if you have a dollar, $1, it can be exchanged with any $1 around the globe. So these are fungible assets. Similarly, you have non-fungible assets like real estate or diamonds. They are known as non-fungible. Each carry unique qualities, and their qualities determine the value individually. So that's why they are known as non-fungible. So when we say that we have NFTs, so NFTs are non-fungible tokens, and they are similar to cryptocurrency because, in a sense, that both use blockchain as an underlying technology. But NFT is not cryptocurrency, and each NFT is unique in the NFT marketplace. As I mentioned in the previous example of the digital land, that we have the Eiffel Tower NFT, we have other NFTs, or we have CryptoPunks or other NFTs. So each NFT will carry a unique identifier through which it can be identified. So NFTs can be anything like games, JPEGs, digital images, NBA Top Shots, even small videos. And these NFTs can be bought from NFT marketplaces, and one can create their own NFTs, sell and buy. So the main purpose of NFT is basically when you have, let's say, a digital picture, okay, and you upload it on a website, anyone can download it, anyone can buy and sell it. You cannot keep track who is the actual owner of those NFTs, those digital content. So they came up with the concept of NFT, that whatever digital content you have, if you register it as an NFT, then you can claim the ownership right of that digital content. And once you have the digital ownership right, you can then buy it, sell it, and claim the ownership of it. That was the actual purpose of NFT. But then people use this concept and start buying and developing different crypto punks or JPEG images, or and then start creating those NFTs. But the actual purpose of NFTs was to make sure uh, uh, to consider the digital ownership right of the digital contents. So this is about NFT. And finally, I just want to share you a warning on cryptocurrency by the Ireland Central Bank and European Banking Authority. They are basically emphasizing, the European Banking Authority is emphasizing that cryptocurrencies are highly risky and speculative and may not be suitable for customers. So they are asking uh, all the European Union residents that do not invest on cryptocurrencies because they are highly risky and speculative, and they are not suited for most retail customers, as an investment or as a means of payment of exchange. So here I conclude my presentation, and I open questions from you.
Thank you, doctor, for your uh, for this beautiful presentation. And actually, first question is I have three questions. So after my questions, then we proceed to audience questions of audience. And my first question is the following, doctor. Um, think that we have a food supply chain. So there are some actors like producers and retailers and consumers and so on. So as a start, let's say, is it expensive? And you actually talked about the energy, right? The big energy that needed to build a blockchain technology. So, and I mean the Bitcoin, something like that. So. Um, is it a hard task for building a blockchain technology among these actors, to connect them in a small, let's say, wireless network, as you showed, in order to, let's say, eliminate the third parties like, retailers, for example, and to build a safe environment, let's say, safe and productive environment for them, among producers and consumers. So, is it a hard task at the start, let's say?
No, this is not a hard task. It's like a database. If you want to deploy a database, you can easily deploy a database. You need to hire a database management system person who make a logical relational database design and then plan it and then deploy it. The same case can be applied in the context of blockchain. The
Hmm.
blockchain can be easily implemented and
Yeah.
designed and planned. But
Hmm.
the issue is that uh, first, before designing and thinking about the blockchain, we need to think whether blockchain is a feasible solution for that scenario or supply
Yeah.
chain or not. And the question that we need to ask is that, do we want to eliminate the central entity? That is the first question. If we want to eliminate the central entity, then blockchain is the
Hmm.
right solution. Secondly, do we want our data to be publicly available to everyone, and every
Hmm.
participant, every entity in the system, in the
Hmm.
ecosystem, can make changes or modify the data?
Hmm.
If
Hmm.
that is right, then we can go for blockchain. Because, for example, if you say that, okay, I'm going to
Hmm.
uh, uh, change the database system of bank to
Hmm.
blockchain. In the banking system, the bank, the central bank or the bank database,
Hmm.
they do not share the complete
Yeah.
authority to anyone else to make changes in the balances. Okay, so if you
Hmm.
want to replace the database to blockchain in banking system, they will never do this, because
Hmm.
they want some trusted party. They don't
Hmm.
want everyone in the ecosystem to make changes. So
Yeah.
if
Yes. Yes. It's not transparent. Yeah. So actually, so these collection of these data, for example, each actor, for example, the price, for example, that. I actually built a transparent environment. So this is my first, and thank you for your answer. And my second question is a little bit general. So and as you said, the first one is you can do it, and so the second one is so okay. So we want to build a blockchain, right? So and under which, let's say, cooperation of technology providers, like telecom operators or software, companies. So it is mostly needed. So which one is mostly needed, let's say, to construct the blockchain application in supply chains, let's say. So for example, like cooperation is, do we need a cooperation between, uh, let's say, an telecom operator and software engineers? So do we have a cooperation uh, for building, this blockchain
no,
in the chain in general,
no,
I mean.
no, because for example, if you talk about Hyperledger,
Hmm.
Hyperledger is a project and they provides a lot of solutions, built-in solutions. If someone is interested, they can just take their solution and they
Mhm.
can use it directly
Mm.
in their case study. If they want to use in supply chain, if they want to
Mhm.
use in retail, if they want to use in education, there are
Mhm.
numerous applications. There are numerous blockchain already built-in solutions
Mhm.
available, and you don't need to rely on each
Mhm.
party. You can just
Mhm.
use existing
Mhm.
blockchain solutions,
Mhm.
and there is a lot of development. And
Mhm.
cryptocurrency is just one part, let's say
Mhm.
5% or 10% application of
Mhm.
blockchain,
Mhm.
but the rest of the 90% applications are there for the real world scenario. For example, in fintech, in retail sector, in supply chain, in
Mhm.
different revenue. So there is a
Yes,
lot of development.
yeah. So the problem is, doctor. So we trying to find as you talk about the Bitcoin. So it's not stable, right? So it is you cannot rely on the Bitcoin. So we need to have a, for example, Euro coin, something like that. That that provides you a safe environment, right? So, for example, you want to buy something and you want to buy that thing. Let's say 1 week later you want to buy the same thing with the same price. So it's like the currency is important in this process. Uh, so one coin is important actually to define, to have the, to run the supply chain. Let's say we need to have a, let's say, coin. So Bitcoin is not good in this process. So, and actually all the cryptocurrencies are not good actually. So these are not, for example, Luna, as you gave an example. So Luna is like collapsed in this year. So I think, for example, in Turkey, so Turkey, for example, as a central, let's say, bank, create a Turkish, let's say, cryptocurrency, and they say, okay, you can, for example, a producer, farmer, you can take that much, let's say, but they just control their, let's say, currency. For example, a farmer cannot get, let's say, more than uh, he or she needs, let's say. So these are all limited by government. And but if you consider that way, then the decentralized situation is like collapsed, I think, doctor, right? So
Yes,
because
yes.
uh
So basically, if you are trying to deploy a blockchain system, you can have your own cryptocurrency, or you can say that you can have your own token
yes, yeah, yeah, yeah,
on that
yeah,
system, and you
yeah.
don't need to go for a central entity. If
Hmm.
there is some regulatory body in Turkey which
Hmm.
ensures the complete, which
Yes.
guarantees the consumer protection, because in Bitcoin
Mhm.
there is no consumer protection,
Yes,
and
yes, yes. Hmm.
but if in Turkey, if you have a supply chain blockchain,
Hmm.
and you can
Hmm.
have your own token or your own cryptocurrency, and the government of Turkey says that okay,
Hmm.
we back that
Yes.
cryptocurrency, we give some guarantee that
Like a
it's
euro,
going to.
yeah.
Yes,
Like a- as you explained, so like a euro, so like a Bitcoin, not like Bitcoin. Everyone cannot reach, let's say, for example, I want to buy billion, let's say, amount of Bitcoin. It's not possible. So it's like you can buy 5 Bitcoin, and that's all for you, let's say. So if you control the currency, I think there will be, safe environment for applying blockchain technology.
yes,
Right,
yes,
doctor?
and that's
Mhm.
why the European Union has
Mhm.
a digital euro. So
Yes.
digital euro is
Mhm.
basically replacing
Mhm.
cryptocurrency. They
Mhm.
want to move euro to digital euro, and it will be served as a
Mhm.
digital
Mhm.
currency.
Mhm.
Similarly, in UK you have central bank digital
Mhm.
currency,
Mhm.
which will be the
Mhm.
replacement of
Mhm.
these cryptocurrencies.
Mhm. Mhm. Okay, Professor. My last question is, so remember uh, I just mentioned about these actors. So if we include one actor as or government, for example, does the government, let's say, play a key role in this process by, supporting this technology both economically, let's say, socially and environmentally? So remember that we under the blockchain technology, every action, let's say, in the chain could be could be seen, will be seen by, controlled by government. So, and it's actually an important advantage for government to check each actor's action during this process, right? So what do you think, doctor?
Yes. So basically, blockchain have different types. We have a
Mhm,
public blockchain,
mhm,
which can be visible to anyone and anyone can participate. And
mhm,
then we have a consortium blockchain. Consortium will become, uh, uh, a permission blockchain where only limited entities can participate
mhm,
and
mhm,
limited entities can have a control. So
mhm,
a government, if interested, can become the part of a permission blockchain and intervene if to protect the consumer rights or to regulate or to investigate or to keep
mhm,
transparency or to make audits and things like that. But
mhm,
blockchain, the concept of blockchain is decentralization, and we
mhm.
don't want any central entity like government to dictate.
Yeah,
Otherwise,
I
there will
see.
be no difference between
I see. So,
the traditional
for
system.
doctor, in Turkey, I think the same situation is true for in Pakistan. So, you need have some fundings. So, for example, government actually supporting you to, let's say, for example, some uh, agricultural, enterprise just taking, let's say, resources, and they stock. So, for example, to check how much they stock by government. So, um, if the government could check the how much, let's say, items you got at the end of this process, then you are like, you cannot stock much more than you need. I mean, so this actually, this can be a first step, right, doctor? So to get the government support, and actually the government also want to support that for a green level, right? Because it is clean, and it is like, the all product which safe, like, and transparent. And so these are actually, this very works, let's say, works very well to government, actually, this blockchain technology. But as you said, right now it's, just taking government out is our main objective to build this decentralized situation, right? Yeah. Thank you, doctor. For now, I finish my questions, and I can get audience questions. So, Berkay, please provide us. Yeah, here. Yeah, this question is also interest me. So, how to use artificial intelligence and blockchain in smart healthcare system, doctor?
So, in a smart healthcare system, when you are using blockchain, you have, for example, you can, based upon the data that are stored in the blockchain,
Mhm,
you may predict using different machine learning algorithms what will be the probability that a certain patient may have
mhm, mhm,
uh, a probability of having a certain disease. So, because all the information will be
mhm,
gathered in a blockchain system for smart healthcare system, so you can apply
mhm.
all the traditional
Yeah, yeah. Mhm,
machine learning or AI algorithms for
mhm,
prediction, for you know uh,
mhm,
analyzing the data.
mhm. Also, doctor, for example, meta heuristics also good to, for example, like, if you want to apply game theory to blockchain, let's say, system, to decide, whether you need to accept the blockchain or not. So to decide whether you can keep it or not. So, for example, some meta heuristic approaches sometimes, for example, I'm using for a like genetic algorithms, or gray wolf optimizer, for example. These are good also. But yeah. So next question. Thank you, doctor, for the next. Yeah. What are the risks associated with the metaverse, and how Web3 could help?
So uh, uh, basically, one of the issue with the metaverse is that you are going in the virtual world, and you will have very less physical appearance. Like in COVID, we were all online, and when we return back to the campuses, to the real world, we really miss the physical presence. So there are some psychological or social aspects associated with metaverse, and the researchers in that area, they are thinking how they can address those risks. But metaverse in itself is opening a lot of opportunities. For example, we can have our own avatars. We can, you know, you know, generate new business models on the metaverse. We can have, buying and say, more interactive shopping over the internet. uh, uh,
Mhm.
so, but the problem is that metaverse will be relying on uh, some digital currency, cryptocurrency, and there are some risks associated with cryptocurrencies as well. And as I pointed out previously, if, for example, if you have a digital asset, uh,
Mhm.
there is no regulated metaverse. There are different websites that are managing their own metaverse. They are providing their own platforms. So what will be the standard? Who will regulate that metaverse? Who will monitor all the activities over there? It's like a game engine over the internet, and anyone can
Mhm.
participate and do
Yes.
whatever.
Yeah.
So there's a need for regulation in a broader perspective, and all the associated risks, according to governance and
Mhm.
management, will be there with
Mhm.
metaverse. Now,
Thank
in
you.
terms of
Mhm.
yes, in terms of Web3, so
Mhm.
Web3 basically is about decentralizing the current internet architecture. Sometimes the governments can, block the internet access to the ordinary people, and they cannot share information. So Web3, since Web3 will be a decentralized, completely
Mhm.
decentralized, so nobody can have that much
Mhm.
control like the government on the oppressed people. So Web3 can help in that perspective.
Yes. Thank you, doctor. So, Berkay, next question. What are the application of softwares for blockchain for practicing? Uh,
So we
for
have we can design and develop our own blockchain using Python or any other open access software, or we can use some existing, for example, solutions by IBM or from Microsoft or from Hyperledger. These are
Yes.
famous softwares that one can use.
Mhm. Thank you, doctor. So, next question, Berkay. The blockchain applications in countering UIVs.
So,
You know,
the answer to this.
man. So maybe communicating with each other, and as you explained, banking system, so we can also arrange those, since they are just um, taking out with the system, let's say, right? So if the communication between them can be arranged as blockchain, so I think we apply, perfectly apply in UIVs,
Yes.
unmarried. So these are, I just try to explain it, but you know the best. I think,
So
doctor. So
currently, I cannot respond to this answer because
okay,
I don't
okay,
remember how.
then yeah, then skip this one, Berkay. Next question, please. So yeah, this actually explained, but doctor, please shortly, if you. Uh,
Yes, so basically, there is no consumer protection of
yes, yes.
cryptocurrencies.
Uh-huh.
If you invest, you may get a lot of profit. If you
Yeah.
may lose,
Mhm.
you lose all your money.
Yes.
So, countries are conscious about
Mhm.
their consumer rights. For example, in Europe, they are very much conscious about their consumer rights. So, there are a lot of people instances where old
Mhm.
people, they lost their whole, retirement benefits
Mhm. Yes.
because they were attracted by these fancy advertisement that if you
Mhm.
invest, you will get double amount.
Mhm.
But then they invested their pensions, they lost their whole pension. So that's why
Mhm.
European Union, it's a combination of 27 countries.
Mhm.
They issued warnings, several warnings to the people that be
Mhm.
careful about investing in
Mhm.
cryptocurrencies, and they are not regularizing the cryptocurrencies because there is no protection of consumers behind it. And as
Mhm.
you can see, in case of Celsius network, they
Mhm.
just froze 1.7 million customers, and all those people got lost their
Yes.
investment.
Mhm.
Similarly, Luna got lost, and there are a lot of instances, and the European Union, European Banking Authority is very much careful and issuing a lot of warnings. That's why it is not being adopted and used as a currency, because there is no regulatory body behind it.
Yes, yeah. Thank you, doctor. So this was the last question. So thank you, doctor, for this valuable presentation. And I would like to, ask you, dear audience, to subscribe this channel and don't forget to like this wonderful video. And thank you, and see you next IEEE Turkey YP webinar. Thank you, doctor, for your support and
Thank you so much,
valuable
Dr.
everything.
Ali,
Everything. Thank you.
thank you so much, Dr. Ali, and thank you so much, IEEE Young
Thank you.
Professional Training Section. Take
Thank
care.
you.